So, Git. It would be hard to believe that anybody has not heard of Git in one form or another, either because they've been sent to GitHub, where you're told you will find the answer to everything you ever needed to know, or because they've tried to use Git, or they've otherwise discovered that it's the best thing since sliced bread, or the worst thing since sliced bread, really. So the question, I guess, the most obvious question is what's Git and what's it all about? First off, you should realize that Git doesn't actually mean anything. It doesn't stand for anything. It's not an acronym. It's just an arbitrary name dreamt up by Linus Torvalds in 2005 or thereabouts, when he was looking for a revision control system or a version control system to help him develop the Linux kernel. And he didn't like the things which were about, and so he came up with his own. So this has been going on for 16, 17 years now, and it's become fantastically popular. I'm not sure that I'll be able to persuade you why it's so popular, but maybe that's something you'll have to discover for yourself. So here are just some key features of it, I guess. First is it's completely cross-platform. It doesn't matter whether you're running Windows or Mac or Linux, you can use Git. Git's used to track the changes in any kind of file. Although mostly people use it for code and text files, you can quite happily use it to keep track of the changes of images or even movies if you want to, but we may see later that that's not necessarily a good idea. It's also excellent for collaborative working. If there's more than one of you working on a project, and especially if you're not in the same place, then it's comparatively straightforward for you to work on your own copy, have your collaborators work on their copies, and then keep everybody in track and synchronized by some remote, usually by some remote server, which for a lot of people is GitHub. If it's open source, it'll be GitHub. There are others. Other services are available, but GitHub's very, very common. Or you can do it, by all sorts of other means. The fact that it's used for maintenance of the Linux kernel, which is vast, should reassure you that your project is not going to outgrow Git. Any of us working on anything large enough to challenge Git is working as part of a very large team. It's very quick. We're only obviously going to deal with a small example today, but changes and updates are pretty well instantaneous, even for relatively large projects. It's very, very quick. And another feature of it is that it's distributed. That is to say, I have a Git repository, and we'll talk about what these terms mean in a minute. I have a Git repository, you have a copy of the same Git repository, and they are the same thing. And not only that, they contain everything about the project. They work completely independently, and if my machine completely dies and loses everything, I can just grab a copy of your repository and I'll have the exact same stuff back again. Development of almost any project is very rarely linear. You have to go back and fix stuff, you have to correct errors, you have an idea you want to try out, but you don't want to destroy what you're already working on. Lots of projects are non-linear. You may work on a feature and I may work on another feature. Git handles all of that very nicely. There's some links at the end, but there's a nice website that's got everything in it. So just so that we have some start towards a common vocabulary, these are some of the key terms that you'll see used with Git. So a repository is the name given to a folder or directory, if you prefer, which contains all of your project files. Now, You can take that as far as you like. If you're working on something that has value and represents a saleable product, you should consider putting in absolutely everything. So your development tools, all of those things, which should you ever wish to come back and rebuild the version that you shipped to somebody in 2016 because it's worth a lot of money for you to fix, everything you need to recreate that should probably go into the repository. But for most people, just the working code and configuration files keeps them happy. An important point about the repository is that it is a series of snapshots in time. Other source control systems sometimes work, or quite often work, by using diffs. That is to say, you have all of your work in the repository, you make a change and you save those changes, and it's literally done the changes, right? So it's gone and it's compared what you've just put in with what was there before, and it's stored only the differences. This makes it quite compact, but it means, for example, if you lost or corrupted the preceding version upon which the current version was based, those diffs mean nothing. Git doesn't do that. Git has a complete copy of everything every time you save a change. And so you can go back to any point in time, and even if you destroy it, which is actually quite hard to do, you can still get everything back. So these snapshots are called commits. And so all of those changes go into your repository, and your repository ends up as a series of commits over time. Commits can have tags, and these are just pointers to individual commits, really. Generally speaking, you don't deal with the tags, and individual commits are referred to by a hash code, but if you wish, you can name those tags. So for example, if you bring out a particular release or an update or a bug fix or something, version 1.0.5 whatever, then you can name that particular commit and always get back to it. And on GitHub, you'll often see releases, and these are just named commits in the repository. The current commit that you're working on is the end of a branch. Because commits are sequential, they all have parents, and you may have commits which represent different sequences of change, but they all eventually come back to a single commit. And so this tree-like structure means that commits are often referred to, or the system is referred to as having branches. I'll show you that graphically in a bit, because it's not something to wrap your head around terribly easily otherwise. So here's a little repository. This is Micromouse code for Portuguese Micromouse, which I had and wrote some code for. And you can see that on 22nd of January 2018, I started off and put in the initial set of code. And then it went through a number of changes. And you can see several branches. They're color-coded. And some of these branches have names. So, for example, origin master, or R1.0. So this little symbol here means that this is a tag. And I've got develop origin and origin head. The meaning of these isn't very important, but head is the most recent one that you're working on. So down here, I went off and made some kind of change. I created a new branch, made several changes up here, and here, where the green and the blue meet, I joined those together to make an actual release. And then before publishing it, I made some other changes. I created a license file, corrected a small error, and then joined them all back together. And the current state of the code is represented by this commit here. which is on my develop branch. This is the master branch. People these days are calling them the main branch for preference, but master is very common. And this is my development branch. So we'll get to an example in a moment, but I just need to try and clarify a couple of other things. So just to reiterate, a repository is a copy of everything that you have. Individual users can have their own copy and work independently. You can use the remote, GitHub often, to coordinate and share changes. It's free for open source use, or you can pay them and keep stuff private. When you have a remote like that, you can pull changes from the remote, and then your local changes can be combined with the remote version, and the whole, hopefully working, bunch of code can get pushed back for everybody to see. Now, because I'm using Google Slides, I can't remember which slide's next. Oh yes, Visual Studio Code. I'm going to run through an example in a moment, and I'm going to do most of the work in Visual Studio Code. So we'll come back to this just as a reference later. So I thought what we might do is have a look at a real problem, one that's actually come up only about a week or 10 days ago, where I have some code at which somebody's found a problem with. So let's see if I can find that. So for the Arduino, I wrote a library to let you use encoders, right? Just the kind of twist and click encoder knobs. And this came about because I'd looked at several videos on YouTube about how different people do this and concluded that some of them were dangerously wrong. And so in a fit of righteous self-righteous indignation, I decided I would write my own. It's, you know, how these things go. And I put the library up on GitHub and published it so that you can open up the Arduino IDE and you can use this library yourself. The publishing process is fairly automatic. And then the other day, somebody said, well, this is all very well, but if you want to have more than one encoder, it breaks. So I thought tonight we would try and go through the business of fixing that. So here's my repository up on GitHub. And this represents a task that any one of you can do. If somebody has a repository on GitHub, you are free to make a copy of it yourself, modify it and suggest changes, push those changes up, and ask the person if they want to incorporate them into their code. And generally speaking, one of the first things you'll do is you'll go to the home page for the repository on GitHub, and you will make a fork of that repository. And all that means is that you make your own copy that belongs to you, that you can work on, and that won't interfere with or upset the original. So we'll go up to here and create a fork. I've already forked it because I was practicing earlier, but I'll make another one. And I'll shove it temporarily in the UKMARS GitHub account. So now this basic encoder contains everything that the Micromouse Online basic encoder repository contained. It's got a README, it's got all of the various files and all these things, all there ready to use. So if you want to get this onto your own computer in order to make use of it, the inviting green button here for code gives you some clues as to what you must do. Now, I have an account on GitHub and I've set up SSH for secure transfer, so I'm going to use that. But if you just want to make a copy and you don't have SSH public keys and stuff, you can use the HTTPS method and you get this URL. I'm going to use SSH. I use this URL. So there's a URL here, and I'll just copy that to the clipboard. Next, I'll go off to my command prompt And by the way, if you download, I'm doing this on Linux, but if you download and install Git for Windows or Mac, you will get a command prompt, a Git command prompt, which exactly matches this. So you don't have to worry about the fact that your life is mostly spent in PowerShell or some other hell. These commands will all work the exact same. Now, the folder that I'm in is where my Arduino libraries are stored. Right? You can copy it anywhere, but for convenience, I'm just going to copy this into my library folder. If I have a look, these are all the libraries that I have installed on my machine. And I'm just going to clone the repository using the URL that I had from GitHub. It's important to note where I am and what the name of the repository is, because it will create that folder. That didn't take long. That's downloaded everything from GitHub. And now I have up here, if you can see my cursor, you probably can't, but you'll see towards the top of the screen, December the 6th, I've made a copy of the basic encoder repository. And if I have a look in there, my prompt changes. And this reminder at the bottom tells me that I have a Git repository. And if I have a look inside that folder, I have all the files that I would expect to see, right? The actual library itself, the examples and all that, plus this directory here called .git. You wouldn't normally see that in Explorer or whatever you use. It's a hidden folder. But inside there is everything Git knows that makes this a repository. If you copy this folder somewhere else, you can do that, but do make sure that you copy the .git directory inside it. Otherwise, it will stop being a Git repository. It'll just be files.
Quick question, Peter.
Yep.
Is that the standard Linux terminal where the prompt changed? I've not noticed that.
This is modified, but
don't worry about it.
Yeah. I have a modification to help me because I'm lose track. But you can always, if you're not sure, right? If it's got a .git folder, it'll probably say so. I can't remember if the Git bash prompt in Windows does that or not. But you can just do Git status.
Yeah.
And it will tell you what it is and what's going on.
Okay, thanks.
So normally you don't see the .git folder, you just see these things that are in there. Anybody know what I was going to do next? No. So here we are, we've got our library, and we'll just demonstrate that it really is a library and does stuff. I have a particular loathing for the Arduino IDE. And I have told it, for the purposes of tonight, to use an external editor because its editor is just that bad. And this, because it's now in the libraries folder, I can always go and open up an example and I will find it there. And the one I'm opening up is the using timer 1 example. It doesn't matter. You don't have to worry about the details of what's in the code, but I can send that to the Arduino that I have connected here. Don't know if you can see that. Can't see my own camera. But it's just an Arduino with a pair of encoders connected. And if I go to the monitor and twiddle one of the knobs, you can see when I turn the encoder one way, the count goes up, and I turn it the other, the count goes down. Right, so just to kind of prove that it's working. And the fact that I have put it in here makes it instantly a library. I could, by the way, if I wish to, go to Manage Libraries and Encoder and you will see eventually. Oh, it's gone. It's gone. There we go. So there's my published library, version 1.05, and it's installed. So there we are. Now, what's the problem? Well, the problem is this. If you try and put two encoders on and run them at the same time, it falls apart. And we need to fix that. Because the Arduino IDE is so horrible, I'm going to fix that using VS Code. So I'm in my library directory, and I can open up Visual Studio Code here. Get rid of the inevitable messages. And this is my folder structure that I had. Now, in this copy of Visual Studio Code, I have added some extensions to help me deal with Git. And I've added 3 extensions: Git Graph, Git Lens, and Git History. And of those, perhaps Git Graph is the most useful. So we can see what down here, having added Git Graph, I get a little button at the bottom. And these are all of the changes that I have made whilst I was working on the original library. You can see the tags where I've done minor releases, because this was also an opportunity to learn how to do releases for Git libraries, for Arduino libraries. It's not a very friendly process, I have to say. Once you know what to do, it just happens, but getting there is tricky. So I have a single branch, main, origin, which is an origin head. This is what I'm working on at the moment. And if I wish, I can do terminal operations in here. This is just like it would be from the ordinary terminal. And away we go. Other things that Git will do for you at the extensions, the Git Lens extension shows that I made these changes, right? If 5 different people had been working on this, and each one had done different lines or whatever, or different sections of code, you can associate that person with that bit of code, right? So this is great. Apart from anything else, when it all goes wrong and you go, no, it wasn't me, you can demonstrate who wrote the code that did what, and have a little chat with them. This is called Git blame, which I think is a little prejudicial, but that's what it's called. And in a complex file with lots of collaborators, it's very handy sometimes to be able to see who's done what and who's, or if you've come across something, after leaving it for a while, to find out what changes have been made and who's made them. So if we go back to the Git graph, for example, I can open this up and see that this change only involved the library.properties file. 1 line was added, 1 line was removed, or if you prefer, a line was changed. And if I click on there, I can see exactly what the change was from one file to the next. Now, I don't know about you, but remembering what happened when something's gone wrong can be a nightmare. And this alone, just this, comparing changes, would probably make Git worth having, even if it did nothing else. So anyway, I don't want to bang on and on until I'm the only one left. So let's see, we've got to fix this problem. So the first thing to do is I don't want to destroy my existing code. All right, although this is a completely independent copy, I don't really want to make changes that are going to kill it. So Git allows you to create branches. And we are going to do that. Oops, get rid of that. And we're going to create a new branch. And we'll do it with Annoyingly, I've turned off one of the tools that makes that easy, so I'll just do it by hand. If I get this right. So when you have a branch, you check it out, and every branch has a name. You can see my prompt has changed to 2 encoders, and if I go to Git graph, right, I have this branch here, and I still have my original main. So I'm creating a new branch in which I want to make changes and test them. And at any point, I can ditch all of that and get back to exactly where I was by simply abandoning the branch. Or if I wish, I can simply move from one branch to the other, and we'll see that in a bit. So the first thing we need to do is create a test case. So I'm going to copy my existing example, paste it in. I'm just going to dash through this. I'm assuming that the mechanics of this is not an issue for people. And so the actual coding changes, which are live and tedious, I will just do. If anybody catches me making a mistake, though, do let me know. So here's my code. I instantiate an encoder like this, and I want another one. So we'll have, we'll call the first one encoder A, and we'll call the second one encoder B. We'll put the second one on pins 10 and 11. We need to make sure that in the time of service we do both encoders. I'll turn off the reverse because I don't really care about that. The system works by having a 1 kilohertz interrupt, and during the interrupt, the encoders are tested to see if they've got change. So we'll have encoder A change is encoder A change. We want something just like it for encoder B. So if either encoder A has changed or B is changed, then we need to print them out. So we'll do the encoder A count. We'll do a space. We'll do encoder B's count. And we will put a new line at the end. Okay, so that should be a simple enough test. I instantiate, I've got a new example. I instantiate 2 encoders. Make sure they're both serviced. Look to see if they've changed. If either has changed, I'll print out the current count. Sounds plausible. What do we notice? We notice that we now have some changes. My prompt has changed, and if I do a git status, it says that I've got some untracked files. So before I go too far, this is my test case. I'm going to make a commit which adds that into the repository to let me keep track of it. Up here, the source control tool tells me that there's a change. So if I click that, it says I've now got a new file called 2 encoders. And if I click that, it shows me what the changes are, which are pretty massive, obviously, because it's a whole new file. I'm going to add that. There are command line versions of all of this, but you know the night will be long enough if as it is. So I'm not going. I can show you what those are later, but it's quite straightforward to do with the command line. But it's much easier to work in VS Code. So I'm just going to add that. That is now staged, ready to commit. And if I had lots of changes in lots of different files, I can stage any individual files or parts of files or any combination I like. Having staged them ready to commit, every commit has a message, and the message will be brief but descriptive. And then click. I didn't save, so that was stupid, but it caught that, sorted it out for me. And if I just pop back to my Git graph, you'll see I now have, this is my 2 encoders branch. This is my commit with its commit message, and we need to test it. Now, Arduino, being Arduino, doesn't let you just go and pick up the new example, because it only scans the library on startup. So we'll just try that again. We'll restart the Arduino IDE. We will, first of all, check that our original example still works and we haven't broken anything. It does, but it's good practice to test. I'm going to open up the new example, which has appeared, right? Because I'm working on the actual library copy. Check that that builds, which it does. Send it off. Open up the monitor. Now, if I twiddle the same knob that I did before, that's not what we had in mind, I wouldn't imagine, right? Both values are changing. The left-hand one is going up and down as it should, and the right-hand one is going up and down with it. And if I twiddle the other knob, they both change together. So clearly it's pretty broken. Right, so we can leave that there. The question is what to do about it. Well, I happen to know, so we can save a bit of time. If I have a look at the actual class itself, the problem is simply that this line here is a static variable, and so it's shared between the 2 instances, and that's not how we want it to be. What we want it to be instead is a member variable. I don't want it to be declared here, and I don't want it static. If you don't follow this, don't worry, it doesn't really matter. I'll just bash it in. There'll be naught anyway, not to worry. And then up here, we need to initialize it in previous. By reading the pin during instantiation, and we need to, we'll leave it there for the time being. So I'll save that. Again, I'm modifying the library code, so I can go straight back here, rebuild it, run it. Open this up. And now, you have to take my word for it, I'm twiddling the knobs. Now nothing happens. This is not much of an improvement, really. So we'll go back, find the offending line, which I happen to know is because of that. Get rid of it, save it. Close. Rebuild again. Open. Left-hand knob, right-hand knob. Victory. Right, so we've made some changes. We've got some success We don't appear to have broken anything else, but we can check because we still have somewhere the original example. So we'll just run that and make sure that that still behaves, that we've not broken something. Right, and that's doing just what it did before. So we're reasonably confident that things are okay. So I'll flip back here now, and I've made some changes to my code. If I click here, I can see exactly what changes I've made. I've added that line, deleted that line, changed that line, and added that line. So I'm going to stage that, add a message. And commit it. Now, to an extent, that's it, job done. But I'm working in my development branch. Okay, I've fixed the bug, but this is not my main branch. I can click on here and go check out branch. And if I have a look at my code, notice that the whole two encoders thing has just vanished. It's just not there anymore because it's stored in the other branch. If I go to here and check out the two encoders branch, it reappears. Okay, so now I have two completely separate versions of the code, one with my change, one without. And the good news is that no matter what I did in here, I have not killed whatever was going on in my original library. But now I want to bring the two together. In this case, it's nice and straightforward, but of course somebody else could have been working on something else at the same time. So, you know, it can get more complicated. I'm on the main branch, and by the way, Visual Studio Code tells you down here in the bottom left-hand corner which branch you're on. And I want to merge these two together. So I'm in the main branch. I can just right-click on two encoders, merge that into the current branch, and there are various options. We won't worry about what they are. We'll just say, yes, we're going to merge. And now you get this idea of branches and branching and merging, right? So this was my development branch. It's been joined into the main branch. And all I would need to do in principle now is to send this back up to GitHub, and it would be available to everybody. Now that turns out to be fairly straightforward. And I'll just switch to the command line because I've turned off some of the handy graphical things. But if I do git status or status, it tells me that I'm on branch main, but I have three changes, three commits, which aren't in the origin, in the remote. And helpfully, almost everywhere in Git, it tells you what to do if you want to publish them. So it says git push. So let's try that. What do you know? No errors, no problems. Let's just have a little flip back now to GitHub. Nothing appears to have changed, but if I refresh the page, you'll see now it says here, add to code example. If I go into the examples, here's my new example. If I go to the class itself, you can see the changes that I've made, and I could stop there. Because this is not the real library repository, and because it's already 9:15, I probably will stop there. In fact, just for completeness, in case somebody picks me up on it, you should know that in order to publish the library and have it picked up by the Arduino IDE, you need to make some other changes. So you need to have changed the version number. If the version number doesn't change, the new version does not get made available through the library manager. So there are changes that I would have to make to these files as well. And I would want to update the README to describe how this problem is fixed and the fact that you can. So there are other things that I could do, but I won't do them because otherwise I'll be here all night. Overall, though, that's pretty much the process that you go through. If you're working off somebody else's repository, you make a fork of it. You clone it onto your own machine. If you want to make changes, it is sensible to create a new branch to work in. Make your changes. Every time you get a success point, make a commit or commits. All right, so you're always moving forward, but don't commit stuff that doesn't work. That's pretty pointless. Okay, so you make some changes, and as soon as you've got some substantive change, make a commit. Mark the point where you are. At any point, you can go back. So if I wanted to, so here's version 1.03. If somebody said to me, oh, there's a problem with version 1.03, okay, if I want to, I can, actually, if I wish, I can create a branch here and check that out. Okay, I could check the whole thing out. I don't really want to do that, but I could. So I could go back and check out version 1.03 and have a look at the code at the state it was then, and be confident that I got everything back all together. Just as an example, if we have a look at this is the code base for my Decimus Micromouse, Decimus 5A. And just out of curiosity earlier, I had a look and it was first committed in the 10th of March 2012 when I had slightly different setup. And during the time between then and now, there have been more than 3,000 commits over the course of 10 years. Some of them major, some of them minor. So there's a commit there. So this was done 10 years ago, nearly 9.5 years ago. No, whatever it was, 10 years ago, to one file. And I changed one value here from 1 to 3, right? So I can go back that far and identify individual changes. And I can even, you can't see it in such a bunch of files. If it wasn't me that did that, I can even find out who did it, right? If we go back to the beginning of that, I did something stupid and I now have 250 uncommitted changes. A mere detail. So the way I do this, I've got, so this tag here is the exact code that ran in Portugal in 2019 for the finals. Okay, so after I finish the contest, I tag the current state of the code at that point. And if I want to, I can go back. This is the exact code that ran at Minos earlier that year. Right? And I can check any of those out and recreate it and run the whole thing again. And all that kind of thing is very, very reassuring. So Git will do a lot for you. It will do a lot more than that for you. But as with many other 80-20 rules, you know, maybe 80% of what you need to do can be done with 20% of what Git can do. Very few commands. All I've done tonight is fork, clone, check out, commit, and push. Okay, and that's got me nearly everything that I needed to do. It will do a lot of other clever things, but maybe for another time. Meantime, when I put the slides out, I've just put some links up for places that you might want to go and get some help or assistance. So I'll probably stop there. If anybody wants to see anything in particular or ask a question, now's the time to do it.
Any questions for Peter?
Yeah, I've got one. The stuff we were just looking at before we came back to the PowerPoint slides at the end.
Yeah, the decimal stuff.
Yeah, that whole screen, is that a GitHub screen or is that a Visual Studio screen? Because I don't use Visual Studio, you see, so some of this is lost on me.
Well, this is Visual Studio Code, not Visual Studio.
Right, so the overall framework is, this is a Git
All of
screen.
This is simply to make it easier for me to show what's going on, right? But I can do everything, if I wish, just in the command line, because everything actually is translated into commands on there, and it will always give you some kind of help. I can see the branches and all that.
Okay, that clarifies that. One other quick question, and it's something that always gives me loads of problems whenever I try and get anything off GitHub. So for instance, at the moment, I've got your Micromouse basic encoder GitHub screen up, and there's a file there that says basic encoder.h.
Yeah.
And if I click on that, it shows me the code, and that's great.
Yeah.
But now if what I want to do is not to just look at it, I actually want to copy that file to somewhere on my machine. How on earth do you do that? I can never find out how to copy anything that is in GitHub onto my machine.
3 ways, right? So this is the file that you're looking at.
Yep.
If you wish, you can copy the raw contents here to your clipboard if it's a single file. Okay.
Yeah.
You can click raw as well. So the raw button right next to that.
I'll go through them all.
Yeah.
So you can copy it to the clipboard directly there.
Right.
You can view the raw file, which just takes away all of the formatting, and then Control A, Control C to copy, and then paste it somewhere. You can go back up to the actual repository here, and for code, you can download a zip file containing everything that's in there, which is if you're not using Git, that's the best way to just get everything, right? And then put it where you want to put it. Or if you think you're going to work on it, if you download the zip file, you don't get a Git repository, you just get the files.
Right. Well, that's what I'm trying to do, because I've had lots of examples where I've just tried to pull up the stuff and I've not wanted to just copy and paste it into something, because I can't paste it into what I want it pasted into. I just want the raw files.
Okay.
And
So
if
I just do that, if I just do download zip,
yeah,
right, and save it to my S drive here, basic encoder main. Notice it says main because that's the branch that we're on, and I'll show you something about that in a moment. Save that. Show in folder. Open it up, and then I get all of the files. But it's not a Git repository; it's just the files.
Oh, right, but that gives you all the files that are in that area.
All of them. Yeah.
Right, so if I just wanted to pull out one of those, there's no way of. If I just wanted
there
to pull out the basic encoder.h without pulling everything else down.
So you could click on raw. If Pete, if you go back to the individual file, if you click on raw, then right click and do save as.
Right. That'll save you doing the copy and paste, but it's rare that you only want a single file. But if that's what you want, that's the way to do it.
So wait a minute. So you click on the file. So I've got it in front of me. Okay, you click
right
click
so
on raw.
You've got this. No, you've got this view. If you just
Yeah.
click on raw,
Yeah.
you get that view.
All right. And
Then
what?
right click, save as, and then you can save it to your local machine.
Oh, right. Okay. All right.
You're frozen. Okay, you're back now.
Okay. Right. Thank you.
Yeah. What was I going to show you? Oh, yes. If there's more than one branch, there isn't at the moment on here. Okay, you can click on here and you can get the branch that you want and download that version, right? Because the versions in the different branches will be different, and sometimes that's important. So if you were downloading firmware for a 3D printer, the Marlin firmware, you don't necessarily want the branch which is showing on the front page of GitHub, for example. But anyway, okay. Anybody else?
Anybody else?
So if you've got something like your a big set of commits like your Decimus thing,
Yeah.
first, does that include all the the ST library hocus pocus stuff?
Only if you have included it
Right.
in your thing, which
and that-
in this case I have. Right,
And that
so
would be, and there'd be a copy of that for every commit that you made.
no, there would be one copy.
Right.
And if a future, so I've got, because I mean your point is well made, right? That the ST libraries are big, and it would be daft to make lots of copies of them. But if I just change some other file, then the new version of just that file will be saved, and a pointer is saved for each of the old files.
Right.
Okay,
So
it's
don't
really-
you get back to the same problem that you were saying that it didn't have at the beginning, where if the original was corrupted, you lose everything? Because
I don't know how it does it, but it gets around that.
Yeah, so
Right.
all of these internally Git is delta compressed, which is what Pete was explaining.
Mhm.
It's also zipped, so the whole repo's a zip archive, and each one of them has got a SHA hash, right? So which was one of the things Linus wanted when he was doing Linux, to make sure that he knew when he got a checkout, all of the files were not corrupted, right? If you're asking if the repo gets corrupted, have you got a problem? Yes, but Git and other version control tools are not a backup strategy for your machine. You can guarantee that that set of code hasn't been corrupted. But if you want to backup, obviously you need to use some sort of backup strategy.
If you can check out a commit, it's good.
Yes.
If you can't, you're in trouble.
Mhm. So what?
Right?
So what
And
would
you
you
nearly
actually back up?
Oh well,
just the folder, the .git, the
whole
that,
lot.
if you back up that folder. And the one big advantage, because it's zipped and delta compressed in Git over previous version control systems like Subversion, all the master copies are on the server, right? Additionally, on your local machine, it kept a duplicate, and the space of those duplicates was actually bigger than the whole history in .git.
Mm-hmm.
But you just back up the folder, and in fact, you can just copy paste the folder, and you've got 2 copies of the repo. Everything is in that .git folder that Pete showed you.
Right.
Well, of course,
So
if
everything,
it's open-
including a single copy of the bits that you never change.
Yes.
Yeah.
Right.
And of course, if it's open source, you can push your repo up to GitHub, and there's a nice safe-ish copy for you.
Yeah, I mean, I'd
In fact,
recommend that's the best way approach. You put it on GitHub and you just do a sync, and it's on GitHub in one.
So it doesn't need to be open source anymore. When GitHub were a standalone company, they only allowed free open source copies. You can have private repos now because they're owned by Microsoft. So they say you can have, you're limited on the number of transactions you can do a month and stuff, but you can put private repos up on GitHub as well now.
Yeah. You do.
And you can set up your own GitHub server. And I know that you've got a Synology box.
Yep. And I've
you can run Git on there and use that to keep stuff backed up. And
Yeah,
safe
and
as well.
I've done that. That works fine.
Yeah,
I did that with all the
server as well.
Android stuff.
Right. Okay.
So yeah, okay, yeah. You just want to make sure that these things don't get out of hand, where you end up with thousands of versions of nonsense, which can quite soon end up filling up everything.
Okay.
Git's pretty compact. The back end, the storage on your hard drive is pretty compact. Even though you've got all the history of the project, it's very, very small.
Yeah.
To be fair, my entire Decimus 5 archive, including all of the Git stuff, I've just checked, is 160 megabytes.
Yeah,
That's
right.
everything I've done over the last 10 years.
So that's nothing. Yeah, basically.
Okay.
What do you mean that's nothing? It's a lot of work.
Nothing compared to the sort of files that we handle these days.
Previously, I used Subversion, and I couldn't go more than a month without corrupting the damn thing. Whereas, within reason, nothing is ever lost in Git. It might take you a long time to find it, but it's never really lost.
One thing to consider about Git is that if you do take a copy, like put it on GitHub, then you've got a complete copy somewhere else. And then if somebody else takes a copy of that, they've got a complete copy. So even if something does get corrupted, other people have got copies, or other copies are stored somewhere else. So it's usually recoverable without any problems at all.
Pete, can GitHub handle files which aren't represented or can be represented as text files?
Yeah,
Yes.
any kind of file you like.
So how on earth does that work in terms of what we were just talking about, in terms of being able to pull down a file? Because if you click on raw, all it does is it shows you the text version of the file. And I've just been looking at, say, for instance...
you're talking about downloading individual files from... That's downloading individual files from GitHub, not a Git problem. GitHub is a website that hosts Git repositories in a nice, pretty format.
Right, but it contains files. So, for instance, it's got the Eagle files for our boards and things. And if
those are text files, by the way.
Yeah, I know those are text files, which is confusing anyway. But I was just thinking, if I had something which wasn't able to be represented just as a text file, can Git?
Yeah, so normally you
handle
do a Git clone onto your machine, David, or you download the zip. It's really, but if you're looking at pulling a specific file, which is not a Git problem, out of a Git repo, out of a GitHub repo, then it's the same as downloading a file on your web browser, right? You have to figure out how, if it says it's a binary file. I was just looking for one on GitHub.
So it's fairly straightforward, Rob, isn't it? Because you would just, if you really don't want to get into Git, then just get a zip download and take what you want out of the zip.
Right.
folder.
Okay.
And you've got it there. So if you don't, excuse me, you don't want to get into getting the whole repo, then you could do it that way.
Okay.
There's a couple of things I mentioned. I use them. I hadn't seen these tools, so I'm kind of going to put some of these add-ins into VS Code, because VS Code, even out of the box, is pretty good with Git and GitHub. Without any add-ins, you can certainly make changes in the code, stage them, give them a name, commit them, get them through. So that was pretty useful to see those extra code extensions. And if you're concerned about lots of command line stuff, then you can use, if you're a Windows user, you can use GitHub Desktop, which basically converts everything into clicks. So you can create branches with GitHub Desktop. You can clone repos from GitHub down to your local machine with literally just clicking buttons rather than having to go through the commands. You can pay your penny and take your choice on that.
If you install Git on Windows, it will also install a Git GUI.
Yeah.
honestly, though, I would strongly suggest that it's worth taking the time to install and use Visual Studio Code.
I
With
agree.
these extensions, it does all of the things that you would wish it to do. I have stopped using any other GUI client for Git, for visualizations, or for actually working with files. Plus, it has become the I was going to say jack of all trades, but that belittles it. It's become a very good editor for almost any kind of task.
Yeah, I agree with that. I think I've used Git GUI. It didn't do much for me at all. It confused me from time to time. Whereas the VS Code, I use the other stuff because I'm using MPLabX. I'm using an old version of MPLabX, so I tend to have to do the Git actions outside the IDE. But the VS Code stuff is really neat. One thing, I'll let you know one foolish error that I made, so you don't make the same one. I was doing what was essentially a quick and dirty change to get some data logging, and I knew I had some Visual Studio, not VS Code, but Visual Studio, Visual Basic Code, and I was just going to hack it around to make a smaller version of it for something that I wanted, particularly because Microsoft had managed to make the serial ports pretty difficult to find in Visual Studio now in their later release. So I just copied the thing across and started happily making all my changes, stripping out all these bits of code that I didn't want anymore. But of course, the GitHub reference actually in the Git repository was pointing straight back to the piece of code that I didn't want to break. So just be careful if you think you're copying stuff around to make a new project. Get rid of the Git repo and create a new one from the source files that you're actually extracting. That was my simple mistake. It's non-terminal because you can always get it back. Okay, it was dumb, but it did have me going for a moment or two there when I saw my original project disappearing before my eyes. Any more questions for Peter, really? Thank you, Peter, for that, because you can easily overload on Git, I think. The main thing is to just start using it, because once you start using it, I think it starts to make itself obvious.
Yeah, I mean, we've only used like half a dozen commands, and it's a lot because I've just ploughed on through it, but there are good tutorials. Go on the Git site. There are some very good introductory videos. And they usually are, they're awful examples that you would never want to do, but just work through them and try a few things. And like everything else, it'll take a short amount of time, but it's a real investment. And I don't understand how anybody could manage without using Git or something of equivalent power these days.
Thanks very much, Peter. I was really looking forward to this, and it's been really, really useful for me. And it confirmed what I thought, which is that I should have been using it for years, and I haven't.
Yeah.
Okay, shall I stop sharing?
Okay.
Are we done?
Yeah, thank you, Peter. Thank you for that. Slides, of course, will be available fairly soon after this if you want to pick up on those. But that was good, heavy stuff at times, but good.